Okay, we're in the homework 9. Again, the hope is that you've paid attention to lectures. You made some attempt to understand the examples that were given to you during the lecture period. We cover, basically 3 models to look at, and then we apply those models to a variety of problems. So when you're doing the homework, what I'd recommend you do is certainly know what those 3 models are. And those 3 models are listed right over here. And they're root problems where you have an a squared minus x squared, or an a squared plus x squared, or an x squared minus a squared. And we went through those 3 in detail, including we talked about, an invertible region. And again, I realize for a lot of students, that's a lot of work. All right. Just even go read that stuff is a lot of work. We go through that over there. I'm going to say for the most part, when you're doing homework, you may want to have your notes out. So at least you can consult your notes. When you get to the exam, though, don't have your notes out. You want to be ready for these problems. So I'm going to say if you can't remember something you're on the exam, start to try things. If they're not working and things are getting worse, try something different. All right. But there's only 3. And then we write, the second one and then the third one. What do? We carefully write problems that represent that model. All right. So what I want to do is I want to do another share with you. I'm going to go back to the homework now. And I think I'm ready. And let me just get my little finger out here and get this thing opened. I guess we'll do number 1. Now, again, I want to emphasize something over here. When we give you homework, and this is so true in textbooks as well, that the first problem should be easier than 2, and 2 should probably be easier than 3. Not always, though. Sometimes the first problem's a killer, right? But right now, what I'm going to claim over here in number 1, that they actually give it to me. They tell me what to do. So what I'm going to do over here is, I'm not going to write too much stuff down, but certainly I'm going to use a substitution they've asked me to do, right? So there's no memorization here. They tell me what to do. So I'm going to write this down. So I got an integration, and that integration is 16 minus 3x squared dx. And they say, use this substitution, x equals, and that's going to be 4 over root 3 sine theta. They tell me to do that, all right? So I'm going to do it. What do you get over here? Dx, and that would be 4 over root 3 cosine theta d theta. So I am now ready to make a substitution. I'm doing the integration using the substitution they've given me. And what would you get? Well, let's write this down. And let's see, you get 16 minus 16, again, because I'm substituting the x, and the 3 would cancel off. I get 16 minus 16 sine squared theta. And then what do you get for d theta? I'm sorry, for dx, you get 4 root 3 cosine theta d theta. All right. And so it looks worse. Maybe. I doubt it, though. I really do doubt that. And I'll go through this. And so I'm going to pull a 16 out from the radicand, and square root of 16 is 4. 4 times 4 is 16. I'm going to pull out a root 3. That would be root 3. And then I get the root of 1 minus sine squared, which is cosine squared. And in this region that we picked, and again, you may want to go back over your notes, that the cosine squared in the region would be a positive. So it's going to be, I should say the cosine will be positive. So the square root of a square is just going to be cosine of a theta. All right. So let me point out what I just did. I just talked through that. And what he left off with, another cosine, which is cosine squared now, d theta. So my goal over here is that I wondered, did I reach the milestone? Was I able to, make the substitution and get things that are simpler? So what you do is you look at the notes, and I see that right now. I clearly see that I've got to that first goalpost, so to speak. I want to keep going though. And what I'm going to do now, well, this relates back to what you did in the prior section with the cosine squared. And I'll just remind you, so we use double angle formulas, remember? So cosine of 2 theta was equal to 2 cosine squared theta minus 1, and the cosine of 2 theta plus 1 over 2 would be the cosine squared theta. So basically, they use that to rewrite this thing, not as square powers, but as linear powers. So 16 root 3. And the cosine squared is going to be cosine 2 theta plus 1 over 2 d theta. Let me keep going. And what do you get over there? You would get 8 over root 3 integration cosine 2 theta plus 1 d theta, 8 over root 3. What's the answer of cosine? It would be sine 2 theta over 2 plus the answer of 1 would be theta plus c. I got troubles though, and I'll tell you what the troubles are. This star is telling me I can't write the thetas down. I got to go back to the x. So someone said, I don't even remember what the x is. Well, that's why we write things down for you. And what is going to be x going to be 4 root 3 sine theta. I'll write this over here. All right, let's see if we can do it. So this is going to be 8. Well, you know what? I guess I should simplify that two theta, right? That'd be too much work otherwise. That's 2 sine theta, cosine theta over 2. Yeah, this is why you need mastery of the prior subjects. Otherwise, this doesn't make any sense to you. You say, where'd that come from? Math 120. This cancels off. What he left off with, whoops, get back to black ink. 8 root 3 sine theta, cosine theta, plus theta, plus c. Let's not forget, I know what this is. I want to tell you what we did in class, which you want to pay attention to. We wrote this as root 3 x over 4 equals sine theta. I'm ready to write that down now. 8 over root 3. Sine theta is root 3 x over 4. I don't know cosine theta. What was our recommendation? A right triangle to help us out with that. And we talked about this in detail during lectures, and it does work out pretty nicely. So it's going to be theta, and the sine was going to be root 3x. This is going to be 4. And what's over there? Pythagorean theorem, 16 minus, well, root 3 squared is 3, so 3x squared. All right, so what's cosine going to be? Well, it's going to be root 16 minus 3x squared over 4 plus, and what's theta going to be? Arc sine of what? Root 3x over 4 plus c. I want to simplify it. And the reason I want to look at the answer key, I'm going to take this number here and distribute across these two terms one at a time. First term, root 3's definitely cancel off. 4 times 4 is 16, 8/16 is a half. We're left off with x. The root is 16 minus 3x squared plus 8 over root 3 times the arc sine or inverse sine, depending how you want to say that. And again, I can't say this enough times. You want to look at the key. And the reason for looking at the key is you want to see if you got the right answer. And certainly I want to point out what I'm looking at. I'm looking at this over here. I'm going to pull it to the side though. And someone says, why do you do that? Well, for one thing, I just want to see if I got it right. And I'm looking. You should look at it too. So I got the first one. I got the second one. Everything looks great. All right. So I'm saying number 1 was done. All right. I want to just tell you what a lot of students do when they're looking at homework. And these are ones that actually think they're good students, and they're horrifically bad. They'll do this. They'll look at the problem, they'll take their finger, and they'll do this. Good, 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 good. And then they go to the next question. They've done nothing except take their finger and do this, as if this means something. This doesn't mean anything. Your intent here is to be able to do work on your own, independently of anyone else, and verify that your work is correct by checking it. Let's go to number 2. All right, let me see if number 2 is on this page. And I guess what I did for number 2 was I put a next page. Let me just do number 2 for you now. All right, and again, when I do this, I know the answer is here, but what I'm going to do is just, quickly go through it. And I'm not going to look at the work until I do the problem. Certainly I might make a mistake, but they give me the substitution. So it looks pretty easy. So I'll write this down for you. And x equals 3 sine theta, and dx would equal 3 cosine theta d theta. I might as well do everything in the problem. You know, x squared is 9 sine squared theta. Let me write this one down. This is 9 minus x squared. What's that going to be? Well, it's going to be 9 minus 9 sine squared theta. I'd factor out a 9. Square root of 9 is a 3. I'm left off with 1 minus sine squared, which is a cosine squared. And if you paid attention to our lecture, you know, these are regions where the square root of the cosine squared is just going to be cosine theta. So it's going to be 3 cosine theta. All right. Another thing I want to do is just the limits. What do I got? Upper limits 3/2. 3/2 is equal to 3 sine theta. And that means 1/2 is sine theta. And what would the theta be for that? Well, that would be 30 degrees, right? Which is pi over 6. And the other one's going to be, you know, the lower limit 0 is when I get, that's for x, by the way, 3 sine theta. And that means theta is equal to 0. So I'm ready to rewrite my integral. And this integral here is going to be rewritten. So the lower limit 0, I did that up here. The upper limit is pi over 6. And then when he left off x squared, I'll write this down for you. Oh yeah, it's already written down. So that's 9 sine squared. The bottom turned out to be 3 cosine theta. And dx turned out to be 3 cosine theta d theta. We're going to look at the key, by the way, because I want to see if I match their milestone, their goalpost, so to speak. And I keep doing this. I mean, what else can I do? I'll write this over here. It's going to be 0 pi over 6. And, you know, 3's cancel off, cosines cancel off. I'm going to pull the 9 out, and that's going to be sine squared theta d theta. And by the way, the reason I do this is, you know, sometimes you would say you might be barking up the wrong tree. I'm going to look at problem number 2. Did I reach that goalpost? The only difference is they didn't pull the 9 out, I did. Okay, so I think I did okay. I want to keep going. And now someone can say, what are you going to do now? Well, it goes back to the very last section we did, which I'm going to use double angle formulas. So let me write this over here. Cosine of 2 theta is the same thing as 1 minus 2 sine squared theta, and 2 sine squared theta is 1 minus cosine 2 theta. And then I think I know it's that is. It says 9, and I would divide both sides by 2, right? So I'll put the 2 over here, 0 to pi over 6. And what do you get there? You would get 1 minus cosine 2 theta d theta. Again, I'm looking to reach my next goalpost, which is seeing if I can get that evaluated. And let's write this down. If it's too difficult, I probably did an error somewhere. And that's going to be, let's see, theta minus sine of 2 theta over 2. That looks familiar, doesn't it? And limit integration here, 0 to pi over 6. So let's keep writing this down. This is 9/2. And this is going to be theta minus, well, remember we just did this, sine 2 theta. It's 2 sine theta cosine theta. So this will be sine theta. You know what? I don't need to do that. And I'll tell you why. I can definitely double the angle, right? I can definitely do that. So I'm going to go right in for the evaluation now. And let me get my eraser out. I don't want to do that. I just want to do the evaluation. So it's pi over 6 minus, what's the sine of 2 times pi over 6? Pi over 3. And that's like 60 degrees. So the sine of 6 degrees is root 3 over 2. Root 3 over 2 divided by 2 is root 3 over 4. And this is why you needed to really spend a lot of time studying when you're in Math 120 so you can do the arithmetic. It's going to be, when I said, maybe I should say the trig because we're doing a trig, but it really boils down to arithmetic. So it can be 0 minus 0, which is 0. Let's keep doing this. Common denominator 12. And that would be 2 pi minus 3 root 3. And I'm going to keep simplifying if I can. 3 goes into 12 4 times, goes into 9 3. So it's going to be 3/8. And then I get 2 pi minus 3 root 3. All right, I'm going to look at the key. This is problem number 2. Yes, I'm going to say it's too much work for me, but you know what? I think you can do it. And I'm looking at it and I'm expecting to see 3/8, 2 pi minus, wow, you got that right too. All right, let's go to number 3, relatively simple question. And I'll look at it. And what does it say? Well, this one looks like a confidence builder. It looks like an easy one. They gave me a substitution. This is number 3. It's on the side for you. They say u equals x squared. This is u substitution, by the way. I'll write down du. That's 2x dx. Let's put our integral down. Looks really simple. So what do I get? I get 9x. So I can pull a 9 out. And then I'm left with x dx. And x dx is a half of a du. And what do you get on bottom? You get the root of x squared minus 4, which is the root of u, which is u to the 1/2. And I think I can handle it. So it's 9/2. And that's going to be u to the minus 1/2. When you add half to it, you get, I'm sorry, when you add 1 to it, you get a half. And then I divide by half or multiply by 2 plus c. And let's see what we get over there. What do you get? Your 2's cancel out. You get 9 root of u. What's u? X squared minus 4 plus c. I realize for some students, this is going way too fast for them. All right. So, I want to say another advantage of having a pre-recorded lecture is you can look at these at your convenience and slow them down, speed them up, whatever you want to do. And we got the blue area. Wow, we got that one right too. That's incredible. So I'm going to go number 4 now. Go to the next page. And number 4. So I'm looking at that. And I hate to tell you this, there's no suggestion given. All right. So someone can say, if there's no suggestion given, right, what would you have to use? Well, I got to figure it out. And I'm going to say, you may want to look back over the notes if you can't remember, or just play around with it. It's got to be something, right? We didn't have many substitutions to use. So I'm going to say the a in this case over here, and blow this up a little bit. So I'm going to say x equals a. A is 2 because 2 squared is 4. And the substitution, I'm pretty sure it's secant, right? Yeah, I think we did that. And then I put down dx. And that's 2 secant theta tangent theta d theta. These are derivatives that you did in math 121. Okay, sorry, I had to get a drink of drink to finish up, getting thirsty. So what do we do now? Oh, let's hope this works. All right, so what do you get? Put a little star here. And you get what? You get 9x, right? So it's going to be 18 secant theta. What's dx? It's 2 secant theta tangent theta d theta. All right, let's keep going. The bottom, that's going to be the square root of 4 secant squared minus 1. The square root of 4, because I pull it out, is 2. And then we left off with the root of 1 minus, I'm sorry, secant squared theta minus 1, which is tangent squared. And in the invertible region, the square root of tangent squared theta would just be tan theta. All right, things are looking pretty bad. All right, maybe we made a mistake, but let's keep going. We'll see if we get the milepost here. So I guess a lot of things cancel off, don't they? At least conditionally so. I can write down what I get. I get 18 secant squared theta d theta. Well, I got to be honest with you. This looked like it turned out pretty nice. So I'll write this over here, 18. What differentiates to secant squared? That's tangent theta plus c. All right. Could I have made a mistake? Of course. We'll look at the answer key. That's why we give you answer keys. Now I got troubles. I cannot have that as an answer. It's an X problem. So let's write this down. And I'm looking at this as a right triangle problem. And I'll put down the theta here. And I'll write this over here. X over 2 is secant, which means cosine of theta is 2 over x. And this would be x squared minus 4. So I'm ready to write the tangent down. It's going to be 18. The tangent is going to be the square root of x squared minus 4 over 2 plus c, which is 9 x squared minus 4 plus c. Boy, that's deja vu all over again, isn't it? All right. And we're getting it right over there. Deja vu all over again. All right. And that's number 4. Let's go to number 5. And number 5, I'm looking at it and I'm wondering what to do. And that's going to be the, let's see, well, it's pretty simple. So number 5, and I'll write this down. So x is going to be a, that will be root 7, because root 7 squared is 7. And the substitution we make is it's a sign problem here, right? Sine theta. Let's write down dx. That's root 7 cosine theta. You're going to notice as time goes on, you're going to get faster. Now, sometimes you get so fast, you get sloppy and you make a ton of mistakes. We're not looking forward to that. So let's write this down. I'll star here to remind me. What's dx? It's root 7 cosine theta d theta. Got a 1. What's x squared? It's 7 sine squared theta. That's not so bad. Then I get the root problem. And that would be 7 minus 7 sine squared, right? 7 minus 7 sine squared. So I'm going to pull out the root 7. And then you have the root of 1 minus sine squared. And that would be cosine squared. And in the invertible region that we defined, this is going to be cosine. All right, let's get our red pen out and kind of cancel things. And I get something that may or may not be familiar. Who knows? So I get 1/7. That'd be cosecant squared theta d theta. So I'm starting to realize that that's really not so bad, because I think I recognize it. I may make mistakes sometimes, but I'm pretty sure I recognize that. What do I mean by that? The antiderivative. So it's going to be minus the cotangent. So minus 1/7 cotangent of theta plus c. And let me look at the my right triangles now, okay? So sine of theta, we'll check the key later, is going to be equal to x over root 7. What does that mean? This is x, this is root 7. This side over here, again, this is theta, would be the root of 7 minus x squared. And what are you going to have here? Minus 1/7. The cotangent would be root 7 minus x squared over x plus c. Let me clean it up a tiny, tiny bit. And what are you going to get over here? Minus. And look at the key. Make sure you're looking at it. Again, for some students, it appears to go very quickly for them. I know that. I'm going to encourage you that you should, at some point, develop the skills necessary to do these problems. Maybe not at sufficient speed, but nonetheless that you can go through that. All right, including if you use a ton of paper to get through it. All right, so I'm going to go to number 6 now. And let me just shrink this down a little bit. And I think I just finished that. I go to 6. And this is number 6 over here. Again, they tell me to use trigonometric substitution, but they don't tell me what to use. And what's this one over here going to be? Well, it looks like the same old all over again. I'm going to write down x equals. And it's going to be 2 sine, and the reason for 2, because 2 squared is 4, sine theta. And then dx, I guess I can write this over here. And what's dx? It's going to be 2 cosine theta d theta. And I think I'm ready to go in. And I'll put a little star here. What's x cubed? It's going to be 2 times 2 times 2, which is 8, sine cubed theta times, well, square root of 4 minus 4 sine squared. Well, that's going to be 2, the root of 1 minus sine squared, which is cosine squared. And the invertible region, that's just going to be a cosine theta. All right. So we've done the x squared, we've done the root. Now what's dx equal to? 2 cosine theta d theta. Not looking good, but you know what? I want to go forward on it. And what do you get? 8 times 2 times 2, which is 32. And then you get sine cubed cosine squared. Well, I kind of remember doing this last time, right? And these are, odd powers. So let me give it a try. I think I can remember that. So I'd borrow a sign, right? And then I'd have, sine squared, which is 1 minus cosine squared theta. And then have a cosine squared theta over here. And yes, we know it's difficult. We certainly want you to try, though. It isn't like we don't want you to try, or you think this is only some people can do this. Every student who's met the prerequisites for this course and mastered the material prior to this should be able to do this over here. So I guess what we do is we do a u substitution, right? So u equal what? Let's see, I think we said it equals cosine, right? So what's du going to be equal to? Minus sine theta d theta. Well, let's go to town, 32. Boy, this is my second substitution. So I'm seeing the sine theta d theta, and that's going to be du, minus du, I'm sorry. And then you get 1 minus u squared. Well, I got to do a little bit of work here. And again, my work may be look a little different than yours, but this is going to be, I'm going to say 32 now. I'm going to factor out minus 1. And what do you get? You would get u4 minus u squared du. And there's a double thing here. I got to go backwards twice. What do you get over here? 32 u5 over 5 minus u cubed over 3 plus some constant integration. Now I can remember u. It's written down. That's what's great about life. When you write things down, you don't have to remember them. 32 cosine to the 5th theta over 5. Oh, let's see. Cosine cubed theta over 5. Get the idea? Plus c. By the way, I know I have to go back. There's 2 stars. I only remember 1 star. Before I do that, though, I realized that, I'm sorry, I made a mistake. I got to erase it. That's a 3. And again, I'm going to do something that you may not appreciate or want to do. And that's the beauty of life. You don't have to do what somebody else do. You have to do what you want to do. And hopefully what you're doing is the correct thing to do. But I'm going to get a common denominator of 15. And then I get 32 here. What would I get? 3 cosine 5th power theta minus 5 cosine 3rd power theta. By the way, you may say I'm really kind of avoiding the inevitable, which is getting rid of the cosine theta in the problem. But I'm going to now factor out cosine cubed. And I'm going to write it as, you know what? I'm just going to go cosine squared. So cosine squared theta, cosine theta, and we left off with 3 cosine squared theta minus 5 plus c. All right, let's go back. It looks terrible, no doubt about it. Do I remember what the substitution is? It was x equals 2 sine theta. I'll write that down for you now. X equals 2 sine theta, which means x over 2 equals sine theta. Do my little right triangle. This is theta. This is x. This is 2. This is 4 minus x squared, the root of it. Let's write this down now. 32 over 15. Let me write over here the cosine of theta, though. It's this. What's that squared? It's this. What's cosine of theta? It's this. What's 3 times cosine squared? It's this. I'll clean this up later, by the way. I'm sorry. I made a mistake already. I got to erase it again. I get a little nervous back and close the other stuff over there. It's 4 minus x squared over 4 minus 5 plus c. Put a little thing over here. Boy, it's a lot of work, isn't it? Let's take a look at this. I'll try to be very careful about it. 2 times 4 is 8. 8 goes into 32 4 times. So 4 over 15, 4 minus x squared, root 4 minus x squared. I got to do the inside now, and I know it looks tough, and I know it's tough. So I get over here, this is a 4, right? So it's going to be 12 minus 3x squared minus 20. I see something happening here. Force cancel. And what do you get? Oops, I don't mean to do that. Sorry about that. I get 15 in the bottom, 4 minus x squared, and the root of 4 minus x squared. Then what do you get over there? You get what? You get minus 3x squared minus 8. Let's keep going. Oh, by the way, I keep forgetting that c, don't I? Oh, this is going to be a long, hard one, isn't it? So what do you get over here? I'm going to factor the -1. And what do you get over there? 4 minus x squared, the root of 4 minus x squared. And since I factor out -1 from that, the final factor there would be 3x squared plus 8 over 15 plus c. All right, let's take a look at our king. Who knows? Maybe I made a mistake. I realize what some students say. They say that's too much work for me to do. I will say this, though. Without an education, you're going to end up in jobs where it's really too much work for most people to do. It's just an endless. I hate to say this. I see people working, and they're constantly working. I mean, constantly working at things they hate doing, too, by the way, with nothing worse than that. Close over here. Push this up. I'm just checking myself, right? And let's take a look at it. I did a quick grab there. Well, I'm definitely seeing this. It's a miracle. We got the right answer. All right, let's do the next one, which I believe is number 7. On the next page, I want to point out that happens to a lot of students is they say, I can't remember. I was listening to Sal Khan the other day. And by the way, I think he's, I like the guy. I like what he does in his things. He explains basically, I think what Sal Khan is good at, he's good at doing homework, right? That's what he's good at. And I think that's how Sal Khan became successful. I mean, he went to high school. He got good grades in high school. He studied, no doubt about it. He went on to probably do really good in the SATs. He went on to, I believe, when I say good, a good's relative nowadays, a school with a big name. And he majored in something where he did his homework. He did well in his homework, and he did well in his test. He got good grades, no doubt about it. When he graduated from college, he got out of college, and he got a good job at a hedge fund. He made good money, but then I guess something happened, right? And I always say there's always a stopping time. He was no longer at the hedge fund. I don't know, maybe he made a lot of money, who knows? Maybe he couldn't stand it. I don't know. I don't know the story, but he ends up basically doing homework online for people. All right. Turns out to be a successful business for him. By the way, I don't know what the business model is, but it's successful for him. All right. But anyway, he goes on these TED Talks, and he says that he actually believes that most people are motivated to learn. Now, I do agree with that, but I can't say this. Not everyone is motivated to learn the subjects they're studying. I don't agree with that. I've seen plenty of students that do not believe they need to study. They're not motivated to study, all right? Even when you give them back a grade that shows a really poor score. Right now, Sal Khan says if the student's getting a poor score, he should just be allowed to go back and keep trying until he masters it. But the key word he doesn't understand, I believe, is not everyone is like Sal Khan, that they're going to keep trying to get it. Sal Khan is the kind of guy that's going to keep trying until he gets it. There's a lot of people out there in the world that are like that. They'll keep trying until they get it. So what are we talking about? Your mastery of prior material. And this one over here says, evaluate using trigonometric substitution, but they go on to say, you'll need to complete the square first. So this would depend on your ability to go back to Math 100 and master completing the square. Let's go for it. So I'll write this down. So 12x minus 3x squared. I would factor out minus 3, by the way. Now, someone says, why is that? When you were in Math 100, that's what your teachers told you to do because they want the coefficient on the x squared term to be a 1. You would get x squared minus 4x. All right, let's see if that's true. Minus 3x squared. Yeah, you get it. So what do I got to do now? Let me point out what you do. Well, as long as the coefficient on x squared is 1, what you do is take half of this, which is minus 2, and square it, which is plus 4. There's a problem with this, though. This is not equal. What I did was I violated the equality now. So what I got to do? What did I do? I actually subtracted 12, which means I have to add 12. I want to see if this works, though. This gives me minus 3x squared. I'll erase this later, by the way. Plus 12x minus 12 plus 12. Well, these things cancel off. Do I get back what I expect? Of course I did. Let me erase this now. This is just me being retentive. And I'm going to write down the perfect squares. This is minus 3, x minus 2 squared plus 12. I'm going to write a little bit differently. I'm going to write it as 12 minus 3, x minus 2 squared. I'm going to do something even stranger. I'm going to factor that by saying 3 times 4 minus x minus 2 squared. All right. So someone says, I don't even know why you did that. I did it because I was asked to do that. Let me point out where that is. They asked me to do it. And I did it. Now, of course, someone says, well, okay, wasted time doing that because it's no use to me. No, it's useful. They wouldn't have asked it otherwise. So I'm going to write this down over here. And then we'll go through the substitution. So what do you get over here? Well, you certainly get a root of 3. Pull it on the outside. And then what do you get? You get the square root. And again, I'm looking at this over here. All right. This here is the same thing as this here. So I'm taking the root of it. So I pulled it to 3, right? So we left off with 4 minus x minus 2 squared. So someone's going to say, which one is this one over here? And again, that's a problem. Yeah, I can't remember. You got to review. Maybe you should take notes or crib notes, whatever. Have a cheat sheet next to you. So I'm going to say clearly x equals, well, the a in the problem is definitely 2 because 2 squared is 4. Now what I'm going to do, I'm going to use the sign. All right. Now someone says a sign of what? Oh, you know what? I'm sorry. I misspoke. I really apologize. I got to erase that. I'm always thinking the x over here, but it's x minus 2. Let me put that down for you. I got to erase it now. Two sine of theta. All right. Let's square it. What do you get? X minus 2 squared equals 2. That's, I'm sorry, 4. I'm sorry. I'm a little tired. Whoops, really tired. 4 sine squared theta. So if I wrote this over here, let's just check it out. You get 4 minus, well, making that substitution, we get 4 sine squared theta. Well, that's pretty simple. It's going to give you what? Square root of 4 is 2. 1 minus sine squared is going to be cosine squared. In the invertible region, the cosine squared is going to be, the square root of cosine squared is going to be cosine theta. So I think I'm ready to write this down. 1 over root 3. And the bottom is going to be just 2 cosine theta. And this is a 1. Now let's see if we can do the dx part now. And I don't know, maybe I can't. So let's put the dx down. I'm looking at this over here. So the dx is going to be what? 2 cosine theta d theta. Let me write that down for you. So it's going to be 2 cosine theta d theta. Okay, let's keep going. And what do you get? You get 1 over root 3. Boy, things work out really nicely, don't you? You get 1 d theta. And what's it going to equal? 1 over root 3 theta plus c. We'll look at the key later, by the way. Here comes my problem. How do I get theta? Well, I'd have to know the relationship. And what's the relationship? X minus 2 over 2 is the sine of theta. So what's going to be theta? Well, let's write this down. So it's 1 over root 3 arc sine x minus 2 over 2 plus c. All right, let's take a look. I'm not beyond making mistakes, but let's see if we met our goal over here, which is really the end of the problem. And lo and behold, we did. All right. So I want to just talk about, you have to realize that there are a lot of really motivated students. So I want to talk about one student in particular, and her name was Deborah Shanks. Whoops, let me get back to highlighter. All right, she did the problem, but she didn't take my hint, and that's fine. Don't take my hint, you don't need to. All right, this was in the spring of 2017 in my Math 122 class. Excellent student, by the way. And what she did, she showed an alternative solution, and her solution was this one over here. She did this over here. Then she went through a bunch of work, and she got an answer. It was completely different than my answer. I'll go to the next page. And she got this answer over here. Now, of course, I looked at her answer. I looked at my answer, and I said, you know what? They're different answers. They look different. But I said to myself, I have to look at your work. So I had to go through every single step of her work. And she shared it with me. And I'm glad she did. It was neat. It was readable. I could understand what she gave me. So what I'm going to claim over here is I am so thankful that a student took the initiative to do something different than the way I told them to do it. Really thankful. I'm thankful they do that. And she was right. But then I had to show that her answer and my answer were equivalent, but they differed by a constant. And that took work on my end. And I did the work. And then I showed it to her. And we compared things. And that's a good thing. You want to get in that group of people, by the way. So let's talk about number 8. And what's number 8? Number 8, evaluate by completing the square. Let me just go through it. I think we've done these before. And again, you may say, I want to try something different. We're not going to deny you that. So I'm going to write down, let's go to the next page because we got the whole blue area over there. And I'll write this over here. So 84 x plus 7x squared. Well, I'm going to factor a 7 out. And why is that? In math, they were told that you were to do that, get a coefficient of 1. And what would that be? 10, 4, 12, right? Let me see if that's true. 7 times 12 is 70 and 14, 84. Good. All right. What do I do now? Half of this guy, again, the coefficient of that is 1. Half of that 6, square it, you get 36. Then I got to subtract, right? Now, what are you subtracting away? Well, you're subtracting away 7 times 36. And 7 times 30 is 210. 7 times 6 is 42. 252, right? Let me tell you what I did. I had 7 times 36. All right, 7 times 3 is 210. That's 30, by the way. And 7 times 6 is 42. All right, so 252. Let me get my eraser out. Okay, what do you get over here? Let's write this down. This is going to be 7 x plus 6 squared minus 252. Well, I'm going to factor a 7 out. And what do you get? X plus 6 squared minus, well, I think we did it, right? 7 times what? 36, isn't it? Let me erase that again. So I think I did okay. Complete the square. So what I want to do is I want to look at the original problem. And I got to do it. All right, so what I'm going to do over here. Let's write this down. So I'm going to make my substitution now. And my substitution is going to be, let's see, I'm going to make the substitution x plus 6 is equal to, again, you may have to think about it, but it's going to be what? I guess this is going to be the a, which is going to be, I'm looking at it, and the a, Well, the A is 1, right? I'm sorry, the A is 6. I'm sorry, 6. And then we'll check it out, by the way. And then what I think I use secant, right? Let me put this down for you too. So it's probably, and this is going to be root 7. And then I get this business over here, which is x plus 6 squared minus 36. And let's see, what would you get there? Well, I guess if you squared, that's pretty simple, right? I guess I could make that substitution now, right? So let's do that. And what do you get? You definitely get root 7. And I'm doing this business over here with the substitution. And we'll do the differential later. So what would you get? You get 36 secant squared minus 36. Pull out the 36. Square root of 36 is 6. And they left off with what? You left off with secant squared theta minus 1. And that would be tangent squared, wouldn't it? And the square root of tangent squared is just tangent theta. Let's see what we get now. Now, here's what I got to do now. What do I have to do? I got to do dx, right? And what's dx? 6 secant theta tangent theta, right? Secant, yeah, secant tan, right? D theta. All right, let's keep going. And the 6's cancel, so I get 1 over root 7. The tangents cancel, and then left off with secant. I want to go back to the problem, and I want to point out a couple of things they asked me to do. And the things they asked me to do, I'll just outline it for you. I'll get my highlighter out. They say Capuina square. I'm thankful for the hint. And trigonometric, I'm thankful for the hint. But then they say something like this over here, LNU where appropriate. I wonder if they're misleading me. But what I want to claim over here is that I'm really happy you got to this level over here. All I'm expecting at this point of the game is you remember that we actually did this one before, but you may not remember how we did it. So let me go back to the notes, and I want to claim it's okay. You can't remember. So what I claim over here is I'm going to read this thing. We want you to read too. All right, I'm going to read this over here. The antiderivative of the secant theta is, in my opinion, not worth remembering. This was derived in class, and it was, but I will give the antiderivative needed on the exam. So what I want to claim over here, if someone in the exam, and maybe I wouldn't tell you up front, but let's say someone in the exam raises their hand and says, you know what? I don't know the antiderivative to the secant of theta, d theta. I would say, okay, I'll give it to you because I don't expect you to remember that. I'll give that to you. But if I give it to you, I give it to everyone. I write on the board. I would never validate your question saying, oh, good for you. That makes the problem easy to do. No, I would just give it to you. And what would I give to you? I'd write on the board. I say, okay, a student asked for this antiderivative. And I'm sorry, whoops, I made a mistake there. I say, okay, I'd ask class, somebody in the classroom asked for this antiderivative. No, you don't need to memorize those things. I'll give it to you. But I'm not going to validate that it's useful to any single problem on the exam. But what's this going to be? The natural log, absolute value, secant, an equals out over here, theta, plus tan theta, plus C. And I would tell the students, yeah, we derived that one. A student wants to know it, I gave it to him or gave it to her, whatever. All right. So I'm going to claim over here, good for them. But this may not be useful to anyone else in the room, and it might be an error. But anyway, I want to know, did I meet this goalpost? Let's look at it. And I'm seeing it right over here. This is when the student's hand would go up and say, could you please give me the answer because I can't remember it. Okay, I gave it to them. So what do they do now? They would use it. They got that right over here. Then the question comes is, could they get this? Are they willing to get that? Let's go through that. I know it's tough, but I want to go through it with you. So what do I know? I'll write down what I know. And someone, I can't remember. Well, it's important that you can remember something. All right. And that's why we write things down for you. So what do I know? I know the secant of theta in the substitution that we've done before is equal to x plus 6 over 6. So that means I know the cosine of theta is equal to 6 over x plus 6. I do my right triangle just to help me out. And what do you get over here? Well, I know the cosine is just going to be 6. This is going to be x plus 6. What's this thing over here going to be? Let me tell you if I can do that. That'd be x squared plus 12x plus 36 minus 36. Wow, look at that. It's x squared plus 12x. Let me get my eraser out. Erase this business over here. And I think I can write down the tangent. Right? You get the idea? Tangent of theta, this is theta, by the way, is equal to this over that. So I'm going to claim over here, I'm going to write this down for you. So the answer is 1 over root 7 ln, absolute value. What's the secant? It's x plus 6 over 6 plus what's the tangent? The square root of x squared plus 12x over 6 plus c. This is the final answer. All right, someone could say, oh, you must have an error in your K. No, let's go through that. All right, what do you get over here? 1 over root 7 ln. This is a quotient, by the way. You should realize a log of a quotient. It's a division minus the natural log of 6 plus c. This together is considered a constant, and that's why I wrote that answer down for you. And that's why I wrote this answer. All right, that's the final answer I would have written down. All right, let me go to the next one. And I want to just, go over that, doing this problem over here. That remember I told you about Deborah Shanks trying something different. And I love people that try things different. And you should always consider that. Sometimes I can't follow what people do. And then I ask them, hey, what'd you do? Then they showed me what they did and say, oh yeah, gee, I didn't think of that. So let's do this one over here. This one says, use trigonometric substitution. But what I'm going to claim over here is that, maybe there might be an easier way of doing it. So I'm not going to deny it. You can do this any way you like. But it does say, and I'll outline that for you. It does say, evaluate the integral by completing the square and using trigonometric substitution. You can do that. It does say that. But I always say hints are optional. So what I'm going to do over here is I'm going to try to think of a different way of doing it. All right. So what I'm going to do is I'm going to write this over here. I'm going to write the integrand down. What's the integrand? Whoops, I did a mistake there. The integrand is y equals the root x 1 minus x. I'm going to square both sides. Y squared would equal x 1 minus x. By the way, I want to visualize the problem. Y squared is equal to x minus x squared. Wow, this looks familiar. So what do I get? X squared plus y squared minus x equals 0. X squared minus x plus y squared is equal to 0. This is an equation of a circle. This is an equation of a semicircle. All right, I want to graph it out though. How do I do that? Complete the square. What's half of minus 1? It's minus a half. Square it, you get a quarter. Let's keep going. This would be x minus 1/2 squared plus y minus 0 squared. You learned about circles in math 100, 119, and they're certainly reinforced in 121 and in 120. This is a quarter. This is a circle. Center is going to be 1/2 comma 0, and its radius is a quarter. Let me graph that real quick for you. 1/2 0. I'll put that over here. That's the center. I'm sorry, radius is 1/2. I'm sorry about that. And it looks like this over here, the circle. All right. And this is a 1 over there. All right. So it's this, but you have to understand it's really not a circle. It's a semicircle. I want to shade in the region that we're talking about over here. And this is the region. That's the integration we're doing. And remember back in Math 121, we spent a lot of time in visualizing areas. You don't lose track of that. And what's the area over here? The area is going to be 1/2 of the circle, which is pi r squared. What's the r? The r is the radius. What's the radius? 1/2. What's 1/2 squared? 1/4. So what do you get over here? Pi over 8. I would consider that a better way of doing the problem, by the way. So let me go back to that. And what do I say? Pi over 8. Exactly what I said over here. Let me go back over that. What did I say? Pi over 8. Did I do what they said? No, I did not complete the square, and I didn't do trigonometric substitution. Let me show you what happens though. So if you get to this thing over here and you do as you were told, you would get something like this over here. And to me, this is a lot more work. It's more work. Make sure you know what that means. You decide what work you're going to put down. Okay? I also want to caution you about using software. This is an important fact over here. A word of caution about using software. I believe it's a simple problem. I really believe it's a problem. So much so that, probably a student in pre-calculus could do the problem. Probably know what the question was. I use Wolfram Alpha though to do that problem over there. This thing here, I actually asked it. And by the way, it gave back so many different answers. I was horribly confused by it. This answer here was the simplest one they returned to me. And look how complicated that is. Look how complicated that is. I mean, it's outrageously complicated. Again, your mileage may vary. I want to say, make sure you can do handwork. Software is not bad, but you're trying to learn things to do by hand. Thank you very much for listening.